Once again, if you're just joining us, welcome. I see that it is 42 after, so hopefully that was enough time to allow people to come in from lunch. This is assessing and improving data quality in the American Community Survey. We have 5 presentations in this session, and the first will be from Joel Alvarez and Eric Ketchum from the New York City Department of Planning. Their presentation is In the Shadows of 2020, Navigating Pitfalls of Using ACS Data After the Pandemic and 2020 Census. Welcome, Joel and Eric.
Thank you, Diana. Can you hear me all right?
Yes, we can.
All right, let me start by sharing screens. And if you would just let me know when you can see the presentation.
I can see it. Yep,
oh, great.
Looks good. Mm-hmm.
Okay, so thank you very much. I'm Joel Alvarez presenting with Eric Ketchum, and today we'll walk you through some research about ACS data limitations. But before getting into details, let me start with a space analogy. So back in the 70s, the US embraced the ambitious Voyager program, taking advantage of a unique planetary alignment to sling probes out to the farthest reaches of our solar system. The mission faced many hurdles, including funding issues, but the probes were reprogrammed mid-flight and have since crossed into interstellar space. The ACS is a similarly ambitious program to collect even more valuable information about our society. But we now find ourselves at a crossroads, having passed into the interpandemic space. And as we'll show you today, this mission needs help. So first, we'll try to convince you, Houston, that we do have a problem, especially from the perspective of a big city planning agency. And then we'll talk about what we can do to pivot and extend our mission. Okay, so 2 issues that have been exacerbated since crossing into interpandemic space. Number 1, diminishing ACS reliability. And number 2, under the heading of control totals, we have an issue of ACS count estimates that can deviate from reality. So let's start with issue number 1 of diminished ACS data reliability. And note, we're going to move pretty quickly through these slides, but we do hope you get a chance to review the details once they're posted. So of course, the year 2020 was unique, but even in 2021, the ACS had exceptionally high non-response rates. In fact, when compared to 2012, we see a 5-fold increase in both the US and New York State's non-response. We don't have stats for New York City, but we see a 4-fold increase in the Bronx, one of New York City's 5 counties. And this increase is alarming for all ACS data users, but particularly alarming for New York City, since the Bronx's 2021 non-response rate was 43 compared to just 15 for the US. So not surprisingly, given this increasing non-response, we also see a big drop between 2012 and 2021 in the percent of initial ACS sampled addresses with final interviews. The US percent was down 12 percentage points from 67 to 55. New York State was down 15. New York City was down 16, and the Bronx down a whopping 21 percentage points from 58% in 2012 to just 37% in 2021. Unfortunately, while our population and housing supply has grown, ACS sample size has remained unchanged since 2012. So fewer final interviews has led to a considerable drop in data quality. And when we examine final interviews as a percent of total housing, we see a 2021 US percentage only 3/4 the size of what it was in 2012. New York City's 2021 percentage is 2/3 the size of what it was in 2012, and the Bronx has almost been halved at 3/5 its former size. So this really suggests we have a diminishing data reliability problem, but how does it impact our work here at city planning? One way to assess this is to examine the impact on our New York City Population Fact Finder, or PFF, application. City planners use this tool to explore, for example, the characteristics of residents in a proposed rezoning. They can select census tracts in the rezoning and then get ACS profiles for the aggregate geography. And while hundreds of characteristics are available in PFF, we selected a host of commonly used demographic, social, economic, and housing variables, so things like median age and unemployment, and we tested out how the reliability of these 5-year period estimates had changed between 2015 and 2021. So we took all New York City census tracts and calculated the median coefficients of variation, or CVs. This is a measure of relative reliability. So we took these CVs for a cross-section of variables and found that the 2015 5-year estimates were almost universally better than the latest 2021 5-year estimates. And you can see that in this chart here. Improved 2021 CVs are colored in blue, while increased CVs with poorer reliability are colored in red. And the big takeaway here is that you see a lot of red, representing diminished data quality across the board. Still, this is track data, and most CVs were already over 20 in 2015. Not reliable enough for most purposes, and such unreliable statistics are grayed out in PFF as a warning to users. More typically, planners will examine aggregate statistics for a group of tracts with greater reliability. So in this slide, we provided median CVs for the same variables, but now for groupings of tracts that approximate New York City neighborhoods. We call these NTAs, or neighborhood tabulation areas. They're commonly used mid-sized geographies, more akin to study areas that planners examine. And here, most of the CVs were below that threshold of 20. But again, we see this upward slide of CVs with decreasing reliability from 2015 to 2021. And for our end users, it means that they're more likely to have grayed out unreliable results and less likely to have statistically significant findings to report upon. Of course, New York City planning also uses 5-year period estimates to create maps, like the ones in our Population Map Viewer application. To explore the impact of diminished reliability on mapping, we use City Planning's ACS Map Reliability Calculator to again assess our selected PFF variables. First, we tested out how well we could map these variables at a tract level using equal intervals. We know that tract level ACS data are not very reliable, so we expected issues, but we were surprised by the substantial degradation between 2015 and 2021. 65% of our selected variables could not be reliably mapped using 2021 data, compared to just 42% back in 2015. Moreover, far less detail could be mapped using 2021 data. So for example, only 11% of the variables could be reliably mapped using 3 classes in 2021, compared to 26% in 2015. Similarly, we saw a decline in the detail that could be shown using our New York City neighborhoods, or NTAs. For example, only 40% of the variables could produce reliable 4-class maps using 2021 data, compared to 61% when using the older 2015 5-year data. Okay, one final point on the impact of declining ACS reliability. It's important for ACS microdata users to realize that their work is also affected. For example, New York City Planning uses socioeconomic ACS PUMS variables crossed by race for its Equitable Development Data Explorer, or EDDI app. This is a tool used to consider racial disparities for proposed developments. Like Population Fact Finder, the tool grays out unreliable estimates, and we noticed a big increase in this graying after updating with 2021 5-year data. And after further investigation, this should not have been surprising, because like Fact Finder summary file statistics, there was a degradation in CVs across most PUMS variables and across race groups, even when comparing the 2019 to 2021 5-year data with 3 overlapping years. And with that, I'll hand it over to Eric. Hello, everyone. I'll talk a little bit about control totals, which for New York City are set at the county level. New York City is somewhat unique in that our city encompasses 5 counties, and the city's border is contiguous with those 5 counties. In New York City, counties are equivalent to boroughs. As I'll show, county-level estimates are generally reliable. However, sub-county estimates are noisy and have wide margins of error, undermining our ability to understand and plan for the needs of our population. For example, by estimating the number of people who may need language services at poll sites. The control totals for the ACS are set using estimates from the Population Estimates Program, or PEP. Here we have New York City's population estimates for vintages 2011 through 2022. With each vintage, the PEP produces revised retroactive estimates to the previous census. Estimates for the same time point can vary quite widely. For example, New York City's estimate for July 2017 was reduced by about 184,000 between the 2017 vintage and the 2018 vintage, largely due to changes in estimation methodology. Also, as we move further from a census, error in the estimates can compound. Despite the fact that the PEP uses generally robust methodologies and the best possible data. In 2020, the PEP underestimated New York City's population by over 500,000, or about 6%. To evaluate the quality of ACS estimates, we compare ACS to Department of City Planning estimates of housing units, a variable for which we can produce a high-quality alternative estimate. We start with the previous census, 2010 or 2020, and add to it city administrative records on housing unit change. Note that these county and city level estimates are also provided to the Census Bureau through our FSCPE representative and are incorporated into the Population Estimates Program housing unit estimates produced each year. So it's not surprising that MALPI on the left and MAPE on the right are extremely small for the city and for the boroughs where those control totals are set. At the sub-county PUMA level, algebraic errors counterbalance each other, but are large on average in absolute terms. Sampling error can explain the difference for many of these PUMAs. We estimate a pseudo MOE here by calculating the average MOE as a percent of each PUMA's housing unit estimate. This average is about 5% each year, but keep in mind that PUMAs have populations of 100 to 250,000. Each of New York City's 55 PUMAs is the size of a small city, roughly equivalent to Yonkers, New York, or Springfield, Massachusetts. Given the number of people living in these geographies, the errors are quite large. And errors for some PUMAs are extraordinarily large, 10, 15, or even 20% in some years, well beyond their margin of error. Note the change in scale on the y-axis here on this slide to accommodate these large errors, especially in the second half of the 2010s. From here on out, all figures show data from the ACS only. If we look at a basic demographic characteristic, persons per household for the city and boroughs, we can see that there's generally little noise in the data and that estimates are fairly stable from one year to the next. The large drop between 2017 and 2018 can be explained by the drop in population estimates that I mentioned earlier, which is not ideal in that it doesn't reflect true changes in population, but it is explainable. And if we look at the numerator of PPH, household population, taking as an example one county, the Bronx, we can see a clear and logical trajectory. The drop after 2017 again reflects the PEP's methodological changes, not actual population changes, but the drop after 2020 reflects population patterns during COVID. But at the PUMA level, these estimates are substantially noisier. Here we have PPH for 5 selected PUMAs in New York City. You can see that there are unreasonably large year-to-year changes of 0.1 or 0.2 or even larger. Changes from one year to the next reverse direction frequently and are generally too erratic to be based in reality. Taking just one of these PUMAs, Wakefield, Williamsbridge, and Woodlawn, which is in the North Bronx, changes from one year to the next often fall within margins of error, but these MOEs are quite large. And again, the changes from one year to the next are too erratic to reflect true changes in PPH. And this introduces difficulty in using sub-county estimates such as these. Again, looking at the numerator of PPH, household population for this same PUMA, there are large estimated increases or declines in population from one year to the next, sometimes in excess of 10 or 15,000, out of a household population of about 140,000. So why do these noisy sub-county estimates matter?
We use the ACS data to understand and plan for the needs of communities in New York City. For example, to estimate the number of people age 85 plus, or the number of people that typically use the bus to commute to work in a neighborhood or an area of the city. As a planning organization, we rely on ACS count estimates for sub-county geographies. If we don't have reliable, reasonable estimates for basic variables like household population, then we also don't have reliable, reasonable estimates for smaller populations and characteristics on a range of topics. That is, there are knock-on effects for the lack of control totals for sub-county geographies. These challenges are likely not unique to New York City. Roughly half of the country's population lives in counties with 500,000 people or more, and many of these areas would likely benefit from improved reliability of sub-county estimates, even in those that have sub-county place-level controls. And with that, I'll pass it back to Joel.
Okay, so on to guidance. So regarding guidance, from a data user's perspective, awareness is half the battle. It's important to be aware of diminishing reliability. It's important to remember that our ACS data are controlled to PEP estimates, and they will reflect any irregularities that come up. And it's important to remember that once you lose those control totals, count estimates can be quite variable. This means tried and true best practices should be maintained. Just because your data were reliable back in 2015 definitely does not mean the same is true today. So flag estimates with poor reliability. Assess the overall reliability of your data sets. Conduct significance tests. Assess map reliability, and when possible, use alternative sources to help assess the validity of ACS counts. And for the Census Bureau, and we know this is a tall order largely out of your hands, but we need an increase in sample size. And we also could use sub-county PUMA controls. Like Eric said, half of our population lives in big counties of 500,000 or more, so many could benefit from such controls. Additionally, and this is really a project for all of us, we need a campaign against non-response, especially by reminding our end users what a critical resource the ACS is. And finally, a couple of relatively easier recommendations. Perhaps it's time to bring back 3-year period estimates. This could help increase the reliability of PUMA data and help us cross the pandemic interstellar divide. 2020 to 2022 period estimates sound pretty appealing as we try to determine the new normal. And as always, the Bureau could help highlight these limitations that we've highlighted here today and double down in the messaging about core best practices. And with that, I thank you very much.
Thank you, Joel and Eric. If you have any questions, feel free to put them in the Q&A panel and we will visit them later. But next up is Stephanie Baumgardner from Census, and she will be talking about how response during ACS's personal interview phase has changed since the start of the COVID-19 pandemic. Let's welcome Stephanie.
Thanks, Diana. Let me know when you can see my screen.
I see it.
Okay, thanks. So good afternoon. I'm Stephanie Baumgardner, and I work in the Operational Performance and Research Branch in the American Community Survey Office at the Census Bureau. Today, I'm going to share how response to the ACS's personal interview phase has changed since the start of the pandemic. As most of you probably know, the ACS is a continuous multi-mode survey. Each monthly panel takes place over a 3-month period with a focus on obtaining self-response in the first 2 months, followed by personal visits to a subsample of non-responding addresses in the 3rd month, which is our CAPI operation. It is changes to response in this CAPI operation that I'm going to focus on today. In 2020, the pandemic drastically affected CAPI operations. On March 20th, CAPI interviewing was halted, and from April through June, interviews were conducted by telephone only. In-person interviewing was allowed again starting in July 2020, but only for areas that allowed it based on local policies and local COVID outbreaks. In-person interviewing was not allowed in all areas until February of 2021. So after the disruption in the CAPI operation in 2020 and the likely changed willingness in people to interact face-to-face with strangers, we noticed lower response rates for the operation, but we wanted to understand how the change in response rates differed by geographic area and subpopulations. So we compared CAPI response rates from the 2019 panels to CAPI response rates in the 2021 panels. This represented the CAPI months of March 2019 through February 2020 and the CAPI months of March 2021 through February of 2022. These rates take into account CAPI interviews and self-responses from addresses in the CAPI universe that were likely encouraged by a field representative. Including both interviews and self-responses from these addresses provides the best measurement of respondent cooperation. These rates are weighted and statistical testing was performed to determine significant differences. To understand how response rate changes differed by geographic area, we computed rates at the state and PUMA levels. We also computed response rates by the Esri Tapestry Segmentation, Urbanization, and Life Mode groups. Esri built these groups using demographic and socioeconomic variables to identify unique consumer markets throughout the U.S. There are 6 urbanization groups representing areas with similar levels of affluence and population density, and 14 life mode groups representing areas of similar demographic characteristics and consumer behavior patterns. We also computed rates for subpopulations using the Community Resilience Estimates Equity Supplement. The CRE Equity Supplement identifies geographic areas where specific characteristics are different than the national average. So on to some results. We found that at the national level, the CAPI response rate dropped by 9 percentage points from 2019 to 2021, from 85% to 76%. At the state level, all states saw a decrease in CAPI response, but Massachusetts, Colorado, Washington State, Wyoming, Idaho, Delaware, and Vermont had the smallest decreases of about 3 percentage points. Connecticut, New York, and New Mexico had the largest decreases at about 15 percentage points. At the PUMA level, differences in CAPI response rates ranged from about -50 to +21 percentage points. So there were some areas that saw an increase in CAPI response, but most PUMAs experienced a decrease. We see concentrations of PUMAs with rate differences greater than 25% in New York, specifically in the Bronx, Brooklyn, and central New York State areas, and in Texas, in the Houston and Austin areas. Using the Esri urbanization group stratification, we see that rural areas had the highest response rates for both 2019 and 2021, and the smallest decrease between the 2 years. Metro cities had the largest decrease. In general, more urban areas, those three at the top of the list, had lower CAPI response rates in 2019 and experienced a larger decrease in 2021 than other areas. Looking to subpopulations, using the Esri Life Mode group stratification, we found that the 7 groups listed at the top of this table had a 2019 CAPI response rate that was lower than the 2019 national CAPI response rate. And all but 2 of these groups had a decrease of 10 percentage points or more from 2019 to 2021. The Midtown Singles groups, described as millennials on the move, single and urban, had the largest decrease and lowest CAPI response rate of all groups in 2021. We also see that the 2 groups with 2021 rates lower than 70%, the Next Wave and Midtown Single groups, are comprised of a younger population in urban settings. Generally, what we see in this data is that areas that we did fairly well with in 2019 had smaller decreases, and groups with lower rates in 2019 had larger decreases. Turning to race, we see that areas with a higher estimate of Black or African Americans had the largest decrease in CAPI response from 2019 to 2021. Hispanic areas also saw a large decrease in CAPI response between these 2 years. Like the life mode group analysis, we see that areas with lower 2019 CAPI response rates generally had larger decreases. Looking at age, we see that areas with a younger population had a larger decrease in CAPI response than areas with an older population. This data, along with the urbanization group data, supports what we saw with the life mode groups, where we saw bigger decreases in CAPI response among younger populations in more urban settings. We looked at additional characteristics as well, and of these, the decrease in CAPI response was greatest for areas where a larger proportion of the people were below the poverty level. However, areas where a larger proportion speak English less than very well and areas where a larger proportion work full-time also saw large decreases in CAPI response. So in conclusion, we saw that CAPI response rates decreased for most areas from 2019 to 2021, but the rate of decrease varied by type of geographic area and the characteristics of the population within those areas. We saw that urban areas had larger decreases than rural areas, and areas with a younger population had a larger decrease than areas with an older population. The Esri Life Mode group data also supports this finding. In addition, Black or African American areas had the largest decrease of all the race group areas. Moving forward, using administrative records data, we would like to compute response rates by race and ethnicity, and also investigate the characteristics of addresses that do not respond. Using all of this information, we will focus research on ways to improve CAPI response and help to inform the ongoing adaptive design work for the CAPI operation. Thanks for your time.
Thank you so much, Stephanie. All right, like I mentioned, the Q&A panel is wide open. And up next, we have Rachel Cortez from Claritas. She will be presenting using ACS headship rates in small area estimates. Welcome, Rachel.
Thank you. Should be sharing. Okay, I think that's it.
I got it.
Thank you so much. So yes, good afternoon, everyone. My name is Rachel, and I'm going to be presenting today on ACS headship rates and small area estimates. And this is research that I prepared with my colleague, Ken Hodges. So Claritas is a data provider, and we build information products for businesses, and those businesses have a variety of use cases for those products. And part of our production process involves creating annual demographic estimates of population, housing units, households, and this is at the block group level for the nation. We use several inputs for this process, which include the decennial census and American Community Survey. Typically, after the decennial census, we would incorporate the latest counts from the summary file tables from the decennial census, which everyone is aware would give us the most detailed data available at the lowest level of geography. But with the 2020 census, the Census Bureau instituted a method of privacy protection that for the purposes of this presentation, I will call differential privacy and have abbreviated as DP. Differential privacy is distinct from previously used methods of privacy protection that the Census Bureau has used for decennial census products. And in the case of DP, the application of privacy protection on the household and person files separately caused inconsistencies between the files when they're combined. For example, you might observe that there are 103 people in a block group and 124 households. Or when looking at the population by characteristics, you might see 34 people aged 25 to 29, but 52 household heads in that age group. The way that we assess these files and observe these inconsistencies is by using the differential privacy, the DP demo files that the Census Bureau provided to the public over the past few years. For the public to assess and understand what DP would mean for many of the products released after the census, they released the 2010 Summary File 1 tables with DP so that they could be compared to the same tables as they were published at the time of their release. For the purposes of this presentation, I'll call the files as they were released SF1 files. It's worth mentioning, though, that the SF1 did have privacy protection measures to safeguard against re-identification. But the SF1 files with the swapping process do not show inconsistencies that we were worried about with the impossible values that I just mentioned. There was always consistency in these files between the household and person levels. We used these DP demo and SF1 files that were provided by IPUMS and used tables from the 2008 to 2012 ACS summary files, as this 5-year file is centered on 2010 and therefore we decided could represent 2010 as close as possible in the ACS. We created tables of population by age and sex and householders by age group from all 3 of these files. We used those tables to calculate headship ratios by age group for all block groups. There are cases when the population equals 0, but the household count is greater than 0, and headship ratios wouldn't compute. However, we didn't want to drop these cases, as they also indicate an impossible situation. So we decided to make those cases where pop equals 0 and households is greater than 0 equal to the number of households. And by including this headship ratio calculation, we were able to create a measure where the higher the ratio, the more inconsistent the data are between the SF1 file and the SF1 file with differential privacy. This table shows the descriptive statistics for calculated headship ratios from the DP demo files. And as we can see, while the mean headship ratios are within bounds, we observed impossible ratios for all age groups, with the ratios being even more inconsistent in the older ages. Calculating the same rates for the ACS with the SF1 file yields no inconsistent values. So now we've established that there are impossible headship ratios, but how often do they occur? To measure this, we created a binary variable that would categorize headship ratios as 0 or 1, where 1 would indicate that the ratio was out of bounds. Because the block groups can have more than one inconsistent ratio, where there are more than one age group provided with an impossible value, we wanted to count these 0s and 1s to assess the extent of the problem and decide how to address it. And this table shows those results. Out of the about 217,000 block groups, about 143,000 had no impossible rates, but one block group had up to 8. So now we know there's a problem that we have to address before Claritas can use the 2020 decennial rates in our estimates process. And since we know that the ACS provides no impossible rates, maybe we could use that to substitute a ratio above 1 with a rate from the ACS. But we had questions about this. Like, if we do it, should we do it for all age groups in a block group with impossible rates, or should we only replace the offending rates? In some cases, there might be unrealistic rates that don't have a ratio that's greater than 1. To make this decision, our first step was to evaluate how different the DP-based ratios are from the SF1-based ratios. We subtracted the difference between the rates and then took the absolute difference and summed that difference across the age categories. Taking the absolute difference ensures that negative and positive values don't cancel each other out. Having one composite measure also allows us to evaluate the differences between the 3 files. This table shows the measure for the comparison between the DP and SF1 and between the ACS. We would expect it would be closer to the SF1 than the ACS, since the DP is based on the same decennial census data and the ACS is a 5-year survey-based estimate. However, across all age categories, on average, the DP headship ratios differed from SF1 by about 0.13545. The smallest mean difference was 0.03748 for ages 15 to 24, which is an age group where very few people are householders compared to other age groups. The largest mean difference was 0.36104 for ages 85 plus, where a larger percentage of population is age group, or a larger percentage of the age group are householders. The largest mean difference, across all age categories, on average, the ACS headship ratios differed from SF1 by about 0.15519. But this is for all block groups, not just those places where the DP-based ratios were above 1. So what happens if we restrict the comparison to only those ratios? As expected, for block groups where the DP headship ratios exceeded 1, the ACS alternative was more similar to SF1. The exact amount is hard to measure where DP population is 0 because the DP headship ratio doesn't compute, for example, dividing 0 by 7. But setting the headship ratio equal to the DP household total could be viewed as a conservative measure of how many out-of-bound headship ratios we found. And we have to keep in mind that a DP ratio greater than 1 is not valid, but it still could be closer to SF1 than a valid ratio from the ACS. So what are our other options? Sometimes when the DP ratio is out of bounds, the ACS may not have an alternative ratio to substitute due to the small ACS sample in some block groups. Or there are no observed headship ratios for one or more age groups, even though there are enough people in the age group in the entire block group. So one idea we had was to substitute the county rate from the ACS when the block group rate from the ACS is not available. And we decided to see if this would be any better than the DP-based data that are out of bounds. The mean absolute difference with SF1 was reduced slightly from 0.248 to 0.235. In other words, the county substitutions enabled ACS to provide a valid headship ratio in many more instances where the DP ratio exceeded 1. And the mean difference with SF1 was actually somewhat lower than before county ratios were substituted. And next, we wanted to determine how often ACS ratios were closer to SF1 than DP ratios when we substituted the ACS ratios, where the ACS BG ratios were not available. The ACS improved in only about 88,000 out of 1.9 million ratios, which is about 4.54% of the total. But this calculation of the improvement variable was applied to all ratios in the block group, not just those where the DP ratio exceeded 1. In other words, the ACS was eligible to improve on each of the 1.9 million headship ratios in the 217,000 block groups. And as one would hope, SF1 ratios with DP were closer to SF1 without DP than 5-year ACS data in most instances. Note that ACS can improve on SF1 and DP even where DP did not result in a ratio exceeding 1, and the DP ratio exceeding 1 could be closer to ACS than to the SF1 than the ACS. Out of 97,000 ratios where DP was over 1, the corresponding ACS ratio was closer in 88,000, or about 90%. In the remaining 8,000 block groups, the DP ratio exceeded 1, but was still closer to SF1 than the ACS. Of course, even in those instances, ACS made some improvement by providing a ratio that was not out of bounds. A hypothetical example could be that if the SF ratio equals 0.95 and the DP ratio is 1.1, if the ACS ratio is 0.7, although the DP ratio is out of bounds in this example, it's still closer to the SF1 than the ACS ratio. This table shows us that when the DP ratio exceeds 1, the corresponding ACS ratio is always valid and always closer to SF1. But what if we summed the DP data to the county and used that in the place of the out-of-bound DP block group rates? Would this do better than summing the block group data from the ACS to the county level? When we summed the DP data to the county level, we observed ratios that exceeded 1 in only 83 out of 1.9 million ratios, so very few ratios are inconsistent at the county level. This table compares the mean absolute differences for differential privacy, ACS, and DP county versus SF1. The results indicate that across all block groups, county DP headship ratios were on average closer to SF1 than both DP block group data and the ACS. So next we wanted to calculate how often the DP county data improves over the DP block group county for all block groups, not just those violating the ratio. When we look at the DP county rates and how often they are closer to SF1 rates than the DP block group rates, we see that while these rates do exceed 1 for ratios in the ages 25 to 34 and 85 plus, it only happens a handful of times. So what if we only looked at the block groups where the rates exceeded 1? For both all rates and rates that exceeded 1, the DP data summed to the county performed better than the ACS block group data. Specifically, it improved 93.5% of ratios versus 90.8% that were improved by the ACS data. It was better for all age groups except for 15 to 24-year-old headed households and 25 to 34-year-old headed households, where the ACS was slightly better. So we know that the DHC data with differential privacy gave us some impossible and unusable headship ratios at the block group level by age. And these inconsistent out-of-bound rates would cause us problems when we tried to use them in our yearly estimates process. We needed to decide what we were going to do in these cases. So for this research, we determined that substituting ACS ratios for the differential privacy ratios, where differential privacy ratios were above 1, improved consistency with the SF1. However, the issue is that ACS data are not always available. So we looked at what would happen if we substituted the ACS county level rates. This again improved consistency with the SF1. We decided the best option was to substitute the DP county level data for the ratios that exceeded 1. Doing this improved consistency, but not much more than the ACS at the county level. Thank you very much.
Thank you, Rachel. All right, keep your questions coming in. And next we'll move on to Ed Kassam. He is with Werner Constam Family Giving Fund, and he will be talking about ACS and census low response in hard to count areas and consequences for community planning and services with Fresno County as a case study. All right.
Well, let me get my screen sharing, I think. I hope it's sharing well. And
Yep, I can see it.
And what I wanted to do is go through some of our observations about small area variations in patterns of ACS and census response, actually starting with census response. And just as a real quick background, Fresno County is a Central California county with a population of about 1 million. It's considered by some to be rural, but it's actually mixed urban and rural. And it's one of the counties, like many others in California, where Hispanics are the largest population group. So the first issue on our minds was, why do local variations in census response matter? And it's obviously been correlated with differential racial ethnic undercount as detected by the PES. And we looked back over the history of the ratio for differential undercount of Hispanics compared to response rate for Hispanics beginning in census in 1990. And as you'll see, it varied from census to census, but unfortunately 2020 resulted in a larger ratio of undercount for each 10% response gap. This kind of issue is, practically speaking, important because racial-based undercounts don't actually address what the situation is in socially marginalized communities with mixed populations. There's also some interesting analysis from the Census Bureau's PES report on housing estimates, which shows that, as is the case with historically undercounted populations, we can look at response rate in relation to PES detected undercount. And as expected, there's much higher emissions of households in the low response tracts than in the high response tracts. So what's the case there is that census and ACS response structural factors matter, not just race and ethnic patterns. And the big example in California is that we look in California and we look at the easier to count tracts in California, as indicated by the California Hard to Count Index, and the harder to count tracts, and the gap in response between the easy to count and hard to count is 17.5%. So this kind of points to the fact that sub-state analyses of census and ACS response, and in fact, we'll argue sub-county analyses are important because the variation in self-response within California is comparable to the state-to-state variation in self-response throughout the U.S. So certainly we see our analysis pointing to the idea that fine-grained geographic resolution is crucial and that it's also possible. One of the interesting things is that California represents a fairly close to best case of Census 2020 response because California used its hard to count index to do a major campaign to promote census response, focusing on the hardest to count tracts. And the campaign, as has been reported a lot, was big, $187 million. And it was conducted everywhere in the state. And it probably did mitigate fall off in response rate. But it's important to keep in mind that the campaign focused on respondent motivation. And it looks like respondent motivation is not the only factor that impedes response. And there I just wanted to note that one factor that impeded response historically, which is limited English, was helped greatly by the bilingual questionnaire. But at the same time, since similar bilingual questionnaires were not available for smaller minority populations like Hmong and Punjabi Sikhs and indigenous Mexican immigrants who often don't speak Spanish even, that problem remains. So we did a streamlined regression model to look at the factors that affected local level of Census 2020 response at the tract level in Fresno County. And even though the California's Get Out the Count campaign had been targeted to the hardest tracts, problems still remained, as you see from the regression here. And the key factors, not surprisingly, similar to ones in the past, were that poverty, percent of households in a tract below poverty, percent of renter households, decreased response. But another factor that hadn't been much addressed in the past is that the percent of non-citizens in the tract also affected response. And non-citizens is a complex independent variable since it's a okay but mediocre proxy for undocumented immigrants, but it includes undocumented immigrants and other mixed status households. The response was much worse in rural areas than in urbanized areas. So these different structural factors interacted to explain what was the local response rate. And an important thing to keep in mind is that this structural analysis did better at explaining level of self-response than analysis based on race and ethnicity, as we see in the PES. So we have systemic factors related to mode of data collection, broadband connectivity in the rural versus the urban areas, affluent versus poor neighborhoods, and that's powerfully correlated with self-response rate. Socioeconomic factors, and I think where this analysis is particularly relevant to California and to immigrants throughout the U.S. is that sociopolitical factors, namely citizenship, legal status, are related to level of response. So this suggests to us that the Census Bureau's low response score, which is a kind of generic algorithm to look at predicting level of response, might well not be quite optimal, that a better one would be a set of related algorithms to predict low response or high response that looks at what are the particular local conditions that make a difference. Let's see if I can go back, as I skipped a slide by mistake. Here's our graph of ACS response in Fresno County and census response. And as you see, response to both surveys follow similar patterns in relation to hard to countness of a local tract. The most problematic thing, perhaps, is that ACS response is much lower, and that it varies in relation to the hard to countness of a tract even more than census response. So we looked at the dynamics of those varying levels of ACS response, and not surprisingly, factors that were similar to those involved in level of census self-response were in play with respect to ACS response also. However, as you see from this slide, the key factors that best explained ACS response level were slightly different and seemed to make a lot of sense, and in particular, the percent of adults without a high school education playing a big role, since the ACS is so much more burdensome than the census. It needs to be said also that in counties like Fresno County, which is mostly Mexican immigrants who came to the area to work in farm work, it's important to note that the planning database variable that we used, which is percent of people without a high school education, isn't quite ideal, because in fact, a high proportion of the Mexican immigrants, about 50%, have only an elementary school education, making the ACS still more difficult. So then we went on to what are the implications, and looked at a rural west side area of Fresno County, which consists of 9 tracts, and looked at what would happen, what was the kinds of impacts there would be on a pretty straightforward census-driven funding allocation formula, which is compensatory education Title I-A. And so that's nationally, it's a big program, $16 billion, $2 billion for California, $100 million for Fresno. And the stakes for this particular cluster of rural Hispanic communities, 11 school districts in the area, is $7.6 million. So the accuracy of both the census and the ACS findings regarding number of children in poverty and population estimates program adjustments for that are really important. So here's the stakes: an area with 53,000 people, very high level of poverty, very high level of people without much education, and high proportion of non-citizens who are being undercounted and in the census and underrepresented in the ACS. So did non-response follow-up cure low census response in this hard to count sub-county area? Probably not. We had survey data which showed that the proxy interviews, which the Census Bureau reported for the area, they was at the predicted level of proxy interviews. However, our previous survey research of Latino, low-income Latino families in the area had shown that a quarter of the proxy respondents said that they didn't know enough to say anything about the characteristics of a nearby household. Moreover, the reason I say that the relationship between differential undercount and census response is still a little tentative is that master address file omissions are very likely to be a factor in undercounting in areas like these, where we know from our on-the-ground research that there's lots of irregular housing, back houses, backyard trailers, converted sheds, and garages. And we knew and had hoped that MAF emissions might perhaps be rectified with infield ads, but we doubt that there were many infield ads given the workload in these areas with very high non-response. So to break the vicious circle, I just wanted to say that two of the factors that come up in our regressions that can be addressed, and one is lower educational attainment being a factor in low response, and the other is internet connectivity. And a key thing that suggests to us is that the Census Bureau really is going to have to look not just at improving broadband connectivity, but also to couple that with initiatives to build household ability to use do internet transactions well. So that's the summary is that ESEA Title 1A is one use case where it's very important to look carefully at the levels of response. And if we do, we can look at what the likely undercount is and what the likely impact is on allocation of federal funding. I think this is very similar to the kind of approach that the curated data enterprise approach wants to use. So it's exciting to see how that will go forward. And the other thing, of course, is just that the Census Bureau, we think, is going to have to look more closely at level of response and undercount within counties, not just at the national level and the state level. And it needs to look at that geographically in relation to structural characteristics of a community, not just in relationship to race, ethnicity, renters versus homeowners, etc. So that's it. Thank you very much.
Thank you, Ed. That was interesting. Moving on to our last speaker, Chase Sawyer from the U.S. Census Bureau. His presentation is called Using a Demographic Frame to Potentially Enhance the ACS. Let's welcome Chase.
Thanks, Diana, and thank you everyone for being here today. I'm really excited, to talk about some of the research and the work that we're looking into inside the American Community Survey Office to take advantage of certain enterprise initiatives. Earlier in the week, we heard from Eli Poehler as well as Sandy Clark about how we're looking at utilizing administrative records throughout the survey, and the demographic frame is another spot where we're hoping we can take some records and put them together and have a much more comprehensive look at the individuals within the nation. And so as I get started, I'm going to go ahead and skip through some of the ACS stuff because obviously each of you know how great ACS is and how important it is and how we publish estimates. So what I will go ahead and just point out, and Stephanie mentioned this in her presentation, but there are three main modes of responding to the American Community Survey. We have our internet response mode, our mail response mode, and then a subsample of those that are mailed that are part of the sample are again subsampled for CAPI follow-up in the end of the second month if they haven't responded. What you may need to learn or know a little bit more about is how the Census Bureau is working to create the demographic frame. And so the Census Bureau has used frames for a long time. The master address file got mentioned earlier today. That's something we use to go ahead and draw our sample and go to households. The hope is, though, that we can use administrative records to go ahead and create a frame that's comprehensive for people and has some basic demographic characteristics and is derived from administrative record sources. As part of that, we'll also make sure that we have unique identifiers for people as well as addresses there. And this will allow the demographic frame to speak to some of the other frames, such as the master address file, and surveys such as the American Community Survey. And currently, the plan is to only have this available in approved internal research environments at the Census Bureau. So the demographic frame does have a number of inputs. Some of the major ones I'll mention are IRS and Social Security numinant records. And then there's some commercial vendors as well as state program data that are all linked in and used to develop this look at all people and places in the United States. And so because we have so many records and we have these person identifiers linked with their addresses, there are instances where we have an individual, but they're found at more than one address. And so a major part of the research we're looking at, as well as the frames team is working on, is when that occurs, where do we put that person and what's the best address for them? And so in this example, we have an individual that has 3 records, and so do we put them at the house? In this instance, there's a dorm, and then there's also an apartment, so we need to go ahead and determine where that individual likely lives. And so this is done through a person-place model. And so this is the process of assigning a probability that a PIC MAF ID or a person address record is at a particular resident at a particular reference date. And so in this example, the person-place model gets run using ACS data where we know the true PIC MAF ID pairs, and then we look at the information we have in the demographic frame, and we're able to go ahead and assign probabilities to it. The current iteration of the frame that I utilized in some of the research results I'll go ahead and present today has a reference date of April 1st, 2021. And again, it has some of that information that I mentioned. So it has a person identifier, an address identifier, basic demographics, as well as geographical information on a person and that household. And so that currently right now on the demographic frame, there are 515 million records. And so just going back real quick to really summarize, and what I'm hoping we can talk about today is how we have this file that now has 515 million records that can be used as a benchmark for different Census Bureau products or as sampling frames. So most of you know that the decennial census is done in an effort to go ahead and be a benchmark for the nation that's done every 10 years that's used for apportionment. In the same way, the ACS creates sampled estimates that are collected continuously, that the primary focus for the federal government is to inform federal funding, but obviously there are numerous other uses that the ACS data are used for. But something I've come up into my career is like, okay, well, how do we make sure these are doing as well as possible? How are we getting close to truth? And that, again, really is my hope that we can use this demographic frame to go ahead and do that we can compare overall counts for ACS publications and look at some of the demographics there and how the population estimates are looking that we use. Also very hopeful, and I'll report out in just a few minutes about some research we're doing to see if we can't look at what we would expect from the household count in the demographic frame and compare that to the household count or the roster we get in the ACS. And that should hopefully help us better understand where we may be undercounting or overcounting individuals. We're also very hopeful too that having access to this will help us to better understand the individual characteristics of our respondents in the sample. And so I do have some results that I'll go over today. I do want to point out that I do see this as analysis of two benchmarks, but neither one being absolute truth. There were presentations earlier in the week talking about how surveys undercount children, especially young children, whereas the hope would be that we would see them in IRS records on the demographic frame. There are some instances, though, where we think ACS gets more on the ground at truth, where administrative records may not be updated as frequently. And so, again, there are going to be differences in our analysis, but they all can be very helpful in understanding the survey and the demographic frame. And so the first kind of set of preliminary estimates I can report out on today is looking at household counts between the frame and the ACS to better understand what differences might be there. This will help us probably better understand ACS roster as well as possible undercounts in the future. And so, and again, we'll look at the results here, and even if they're not perfect, this still lets us better understand data quality and possible concerns. And so a caveat to be aware of here is that we are using a reference date on the frame that is April 1st, 2020 for the date of this decennial census, whereas I'm using 2019 ACS data, which is collected continually throughout the year. We're also going ahead and we're subsetting only for households that we think are occupied based on ACS and the data that are on the frame. And so here, looking at the household counts between the frame and the ACS, we see that 64% of the time we have an exact match between the ACS roster and the number of individuals that the person-place model would assign to an address. When we look at the sides of the results, we see that the frame has more individuals in the household about 23% of the time, whereas ACS actually has more individuals in the household about 14% of the time. So again, this gives some credence to the idea of, okay, maybe there is some undercount in the ACS. But again, we want to research this more before we make definitive statements like that. I will say as well that I expected this to line up more. I was hopeful that household counts would match a heck of a lot more. But again, I think this gets at the mobility that we actually have in society, where individuals may be moving to go to school and they may get counted at their dorm instead of on the ACS. There's also individuals where parents may be separated, and putting the child in the exact home according to our residence rules can be confusing. But again, this is helpful because it helps us better understand our data. I'll say as well, it also is helpful as we understand our response mode. So I went ahead here and I broke out our data by our response mode. And you can see that our internet response mode, we have exact matches for household count about 64% of the time. Mail is at 70.2% of the time, while our personal interview is at 48.1% of the time. And so, again, I don't show this today just to throw our interviewers under the bus and say, oh, this rate's much lower. That CAPI subsample is a much harder group to go ahead and collect information for and understand. And there are reasons why it may be more mobile. But again, this is exciting to us that we can see this and we can start to think of ideas how we might look at why that roster count is different and maybe model out what are the exact reasons we see differences in those modes. Another set of analysis we went ahead and did was looking actually at the individuals and trying to understand how often the person location match between ACS and the demographic frame. And again, this will help us to better understand individuals as well as provide information to the frame team about what we may be interested in having for a reference date in ACS. While the team initially was focused on the census date of April 1st, there are reasons why we may want to have additional dates for ACS to look at. And so again, this is looking at April 1st as the reference date. That's a caveat to be aware of. And then also about 5% of the records can be linked to the administrative crosswalk. So those are excluded here. But when we start doing this analysis, we are able to find that individuals that were reported in the 2019 ACS are found on the frame and at the best address 76.8% of the time. When we look at another category of the person being found on the frame, but they're found at a different address on the frame that wasn't listed as the best address from the person place model, find that occurs 9.4% of the time, which brings us to about 86.2% of respondents have an address match between the frame and the ACS. There are another 10.3% of ACS person records that are found on the frame, but the respondent address that we have from the ACS doesn't match any address on the frame. So that brings us to about 96.5% of ACS respondents that are found on the demographic frame, but for some reason, IRS records or program participation didn't find those 10.3% and have them as part of the frame. So we're interested in finding out more about that. And finally, to close out, only 3.5% of ACS respondents were not found on the frame. And so I've talked a fair amount about the person place model and how it's important for ACS to better understand what reference date we might need. And you can really see this here with some of our panelized data, where that respondent being at the best address increases as we get closer to the reference date of April 1st. So in our March panel, it was 76.9%. July, it increases to 79.3%, and then October, it's 80.5%. So again, as we get closer, we see better model performance. We also see that as we get closer, there's more match between individuals and that there are less individuals not found on the frame. And so as I go ahead and close out today, I will say that we do have a lot of interest in other things. We can look at this as opposed to even just looking at quality for our instruments, our data collection instruments. Stephanie did a wonderful job of explaining how we're seeing differences in response rates. And we often hear from time to time that individuals would want response rates by different race and ethnicity groups. But we're unable to provide that because ACS doesn't know what a person's race or ethnicity group is until they respond to the survey. And so we did this proxy where we're doing geographic look at the data. My hope is in the future, if we have the frame and we have the basic demographics there, we could actually look at creating response rates by different race and ethnicity groups. And again, that would be extremely helpful to the Census Bureau as well as data users. Also, we've talked a lot about declining response rates. And as part of that, we're trying to do more with monitoring non-response bias. And so again, in that same vein, the hope is that the demographic frame would allow us to do more non-response bias and do it quickly. And so again, just to summarize, going forward, we really are going to work to understand the difference that we have with those household counts and response modes. And again, really trying to model out, okay, is it the response mode that's causing us issues with the match, or is it individual characteristics, and how important are each of those? We also want to look at going ahead and applying maybe indicators. So instead of just trying to get the number to match exactly, could we do something where we're just, okay, we expect a child to be in this household. If someone doesn't report any children, maybe that prompts the FR or the instrument to provide more questions to make sure we haven't left anybody off. We're also, again, exploring how we can better use this in ACS production. Looking at what would be the best reference date compromise between the frame team and the ACS team. We're also very interested in using the demographic data from the frame as part of the ACS edits and imputation process. As Sandy Clark mentioned that yesterday, with Asian sex being potentials for edits and imputations. And finally, again, we want to see it come full circle where ACS data can then help the frame so it can help other programs at the Census Bureau. So I'm very grateful for the opportunity to present on this and any questions you may have. So thank you, everyone.
Thank you, Chase, and thank you to all of our panelists. And I do see some questions coming in, and I even see panelists replying, so that's wonderful. First question is for Chase. What linkage software did you use?
Yeah, so I have to admit, I'm not someone that's really involved with the linkage. The Census Bureau uses it's a PBS system, so it's something designed at the Census Bureau. I can go ahead and provide information in the chat about that process, but I have to admit, I'm not terribly aware of it. I just am lucky enough once it's linked, I'm going ahead and using it.
Sounds good. And actually, I'll invite all of our panelists to turn their camera on. We do have some general questions for everyone. One comes from Jonathan. He says, wondering if anyone has seen this issue. Flint's 2020 ACS population had about a 15% overestimate of population compared to full census numbers. This may be related to the fact that estimates don't take into account condemned but not demolished housing or vacant but not for sale properties. So maybe, I don't know if people from New York or from Fresno have opinions on this. I know our other three presenters were much more nationally focused, but if anyone has any thoughts.
Yeah, you know, we have seen this dissonance between what we believe to be, you know, a housing unit count and the estimates program housing unit count, but I can't speak to this degree of dissonance that we have not seen that in New York City. Do you want to add anything, Eric?
No. Yeah. Well, what I could add is that actually, unfortunately, many of the counties in California don't actually have the budget and staffing to actually do very well at dealing with updating their records. I keep on suggesting that if every place had the budget and skills that the New York City team had and did as good, local address canvassing as Joe Salvo and his colleagues Joel and others did, then it would be great. But as we saw in the 2010 evaluation of Luca, a lot of counties were not prepared to participate at all, and others which wanted to participate weren't able to do a very good job of it.
Okay, thank you for those thoughts. I do see another general question for our panelists that actually came through the chat from Francisco. He says, would the synthesizing data be a good way to address the lower response rate? The synthesizing data means to combine several data sets. This way you can reduce the number of questions for respondents. I'm curious about your thoughts on this. I'm not sure if that was directed to a particular panelist or just a general one. So Francisco, if you want to say who you wanted to direct that question to, go ahead and type it in the chat. Okay,
I'll just jump in. I can't speak. My expertise, I probably couldn't speak much to the synthesis of the PUMS data. I know that's something that probably is much more complicated, but I will say that the Census Bureau has programs such as small area income and poverty estimates, as well as health insurance estimates. But yes, they've done this for a long time where, yeah, they take the 5-year ACS data, but then they use small area modeling and tax records to go ahead and get a 1-year estimate for all counties that's more statistically reliable over time. So yeah, I would think that would be a good thing. The problem that I think you get into is, okay, you have to do that for every estimate or this and that, which would probably make it much harder for a application like New York Planning Office has right now, where you're looking at a number of different variables.
Thank you so much. All right. Looks like we do have time. I know some of these have been answered via text, but we have some time to discuss them too. So the first one was for Ed. Understanding that census geography has trouble with scale of counties in California, have you thought about leveraging Puma level data as opposed to county level data? And I'm sure Ed's response is visible to everyone, but I'll give you a chance to respond orally as well.
Sure. Well, I just wanted, what I'd said overall was that the Puma level of analysis, which is typically a county level or 100,000 people, I believe, is not adequate to correctly represent the characteristics of communities within many counties. And it's because the diversity is so fine-grained. I think that if one looks at Pumas, at counties' Pumas, to see how homogeneous they are or not, one can assess whether the Puma level analysis is going to be helpful or not. But in the cases of places like a good deal of Los Angeles County, which we've looked at, and Fresno County, as well as other counties that I know fairly well in the San Joaquin Valley, the county level analysis would be very misleading when one wants to look at what's going on in a particular sub-county jurisdiction.
Mm-hmm. Mm-hmm. Thank you. Just a friendly reminder, we go until 3:10 or 12:10 for whatever time zone you're on. So we do have time for additional questions from our audience. We'll go to this one here. This one is for Joel and Eric. Let's see. Could you please share your thoughts on the discussion about replacing PUMs with synthetic data and the potential impact of this on reliability and representativeness of diverse subpopulations in NYC? And I do see your response, Eric. Also wanted to give you the chance to respond orally.
Sure, thank you. Yeah, this is a very interesting question, and we're very curious to see how this new process or new technique of disseminating data may affect the PUMS estimates. But right now, we don't have enough information to know exactly what those impacts would be. We're really looking forward to hearing more about this as the Bureau puts out more information, and then we can assess what the impact would be locally for the various ways that we use the PUMS file here.
And a concern might be the loss of our ability to quantify the reliability of what we're looking at. So that could be a concern, but we're very interested to hear what the proposal is, the details.
Mm-hmm. Okay, another question is, in your experiences, how receptive have your elected officials been in addressing this long-standing issue of sample size and reliability? Again, I'm not sure who that was directed to, but if anyone wants to respond to that one.
we haven't. I mean, this is we raised this issue, but I think it's come up a lot. And the Census Project recently highlighted this issue. It is an issue for our elected officials, particularly in Congress. But we have not reached out to individual politicians, and so it's hard for us to respond on that one.
Yeah. If I could add, just in the counties that I've talked issues over with, few of the officials have time or level of attention to pay attention to those concerns. And even in many cases, the data users, say the planning department, is not prepared to deal with those issues, in part due to their workload of day-to-day things they're doing, budget, and lack of sophistication. So I think it implies, for me, the idea that the Census Bureau could, and it sounded to me from Sally Ann Keller's remarks on the first day, that the Census Bureau can really accomplish a lot by reaching out to those data users.
Excellent. Yes, I know we have about 2 minutes left. I just want to encourage everyone to give our wonderful panelists a round of applause. Thank you so much for your wonderful work and also your presentations. I don't see any more questions coming in.